In this video, we will look into how Geologica, an oil and gas laboratory equipment maker, uses CUI Devices AMT encoders and Servosila brushless motor controllers in a new machine's design. Geologica makes laboratory machines that analyze samples taken from oil wells. A new machine that they are working on features multiple servo joints equipped with Servosila brushless motor controllers and CUI Device AMT encoders. The AMT encoder uses a variable capacitance technology to measure shaft angle. The principle of operation based on capacitance is what distinguishes this encoder from magnetic or optical encoders. Rotation of the encoder's input shaft changes a capacitance measured by the device. The measurement of the capacitance is then converted into an angle measurement, which is then delivered via a digital serial interface. Servosila brushless motor controllers are miniature embeddable control units for servo, direct drive, robotic, traction, or other motion control applications. Servosila brushless motor controllers come with a unified connector for interfacing encoders via several kinds of digital interfaces. The Servosila controllers come in a rectangular or a circular form factors. The circular-shaped controllers are optimized for robotic joint designs. For demo purposes, I made a cable that interconnects the AMT encoder and a Servosila brushless motor controller. The encoder provides a single-ended SSI interface, a digital serial interface that connects to SPI pins of the controller. In the Geologica design, a Servosila brushless motor controller is hidden inside the servo joint's housing. An AMT encoder is clearly visible. The Geologica design makes use of frameless brushless motors to actuate the joints of the machine. Frameless motors do not have an enclosure or bearings, and instead come as a set of two separate components, a stator and a rotor. The stator is connected to a Servosila brushless motor controller together with the encoder. Let's do some tests with the encoder and the servo controller. I connected my servo controller to a power supply. Note that the encoder is powered through the servo controller. The servo controller has a built-in voltage converter for the purpose of powering external encoder modules. I use a regular USB cable to interconnect the controller and a computer. We are going to use the computer to display telemetry data coming from the encoder. The encoder sends measurements data to the servo controller via a serial interface. The controller then relays the data to the computer via its USB or CAN bus interface for telemetry purposes. Now we need to tell the brushless motor controller what kind of encoder is connected to it. To do that, let's launch a configuration software tool called Servoscope. Once the controller is powered up, it will appear in the list of devices in the Servoscope window. Set a configuration parameter called servo encoder to SPI. Open up a section called peripheral SPI encoder. I have already configured various parameters of the SPI interface to match those of my AMT encoder. I own a 14-bit encoder, so the number of counts per revolution is 2 in power of 14. The total number of bits in SPI packet and the location of the angular data within the packet can be taken from the encoder's datasheet. The frequency of SPI clock pulses, as well as the frequency of encoder data reading, are set to match those of my encoder's maximum specs. Check a document available online for step-by-step instructions on interconnecting CUI devices encoders and Servosila brushless motor controllers. Now let's look at the encoder's output in the servo controller's telemetry window. When I spin the input shaft of the encoder, the telemetry readings change as expected. This is a demo. In production, please make sure the encoder is properly mounted to get dependable angular measurements. The CUI Devices encoders enable Servosila brushless motor controllers to perform servo, direct drive and gimbal control functions. I would like to thank Geologica for allowing us to use their engineering footage in this video. Thank you for watching. See you in the next video.